Assalamu alaikum. Today's video is about my sport framework, which it is a Huawei deep learning framework. So in this video, first we will talk about the basic step of producing a deep learning model. Then we will talk about the basic concept of deep learning, and at the end we will try a basic example about from of the official website of mindspore about classification. So let's start. As I said, mindsport is a Huawei deep learning framework. There is two type of mindsport. There's only mindsport, which is can use for training and producing the deep learning models and deploying that model in the end user device. And there is the second one is mindsport Lite. In mindsport Lite, it's used for only deploying the model in the edge device with more efficient performance and hardware resource usage. You can choose mindspore by Python or C++ or Java code. Now we'll talk about the basic steps of producing the deep learning model. First thing, you need to prepare a dataset. What is dataset? Dataset is collection of data that you need to use to train your model. Which is dataset is the main concept of AI application. So you need to choose a suitable dataset. Like for example, if you work in vision application and you need to detect a car, you need a dataset that contain a car image. Dataset you can make your own dataset or you can download a dataset from a free website. After you choose your suitable dataset, then you need to choose a deep learning framework. In this situation, of course, you will use mindspore framework. After that, you need to use that framework and dataset that you download to train your model multiple times. After training, you will test your model. If your accuracy and you get good result of prediction, then you can deploy your model in your device or in whatever your application. If the accuracy is still not good, retraining until you will get the uh, commanded result. Training time can be very large and uh, maybe will take a days. It's depending on the dataset or the type of your application. Now we will talk about deep learning. Deep learning is part of machine learning, which is more complex and it uses deep neural network. Neural network is a efficient and successful algorithm that used in the machine learning application, and it's well known in AI world. So, and when you will use deep neural network or longer neural network, that means deep. You will work with deep learning application. The main feature of neural network is that contains three main parts. First part is the input part or layer. The second the second part is the hidden layer, and the third part is the output layer. The number of input layer and output layer depending on your application. For example, for the output, if your application is about to predict the image if it is a cat or dog, you will use only two output node. One give the percentage of cat probability of cat, and the second one give the percentage of the probability of dogs. The higher percentage will be chosen as a result. Also, the input number of input also depending on your application, and it can be any type of input. It can be pixels, image, or a number, any type of data, depending on your application. The hidden layer that contain different type of nodes and different type of shapes depending on your application, and all the process will be in this layer. Now we'll talk in details about neural network. As I said, it's contained from three main layers: input layer, hidden layer, and output layer. And this type of connection, which is every output of the node, is connection with every input of the all the node in the next column, named dense network. So as you can see, every connection between nodes is represent a multiplication of a hyperparameter or a variable named weight with the output of the previous node. So every line have its own variable, weight variable, and different value. And every node in this neural network is just represent a summation of all the output of previous nodes. And in the output of the node, you can see it. You can find something named activation function. The main duty of this function is just limit the output so it does not go very large or to infinity or very low to minus infinity. So the output will be limited according to type of that activation function that you use, will be limited maybe between 1 and or minus 1, or can be limited between 0 and 1. So we have input data, different input data for every node. This value of input data will be multiplied by the weight variable for every line, and the result of this multiplication will be summed in the node, and this process will continue until we reach the output layer or output node. In the output node, the output will be the production percentage for every node. Like as example, if the model is about to classify dogs and cat image. If we have image and we just want to classify dog and cat, the output will be production percentage for the dog and the percentage for the cat. The higher percentage will be chosen as the output. In the training stage, when we will use the dataset as samples as input, and we will get the output, we will compare the model output with the real result. The real result will be all as a part of the dataset. The dataset will contain data and the label for every data, or in other words, the real result for that data. After we will get the output, we will calculate the loss value using the loss function. There's different type of loss function, of course, and we will choose depending on our application. After we calculate the loss function or the difference between the output and the real result, we will use this value to adapt or update the value of every weight or hyperparameter and this connection, and we will repeat these steps until we will get the perfect weight values that output correct prediction. Now we'll talk about an important terms that we will use in the neural network and model processing, model producing stage. First one is loss function. As I said, when we will use the dataset data, and we will get the output. We will compare the output with the real result using the loss function, and we will get the value. This value we will use in the optimization of the value of the weight or the hyperparameters for every connection. Second terms is the batch size. The dataset will be usually will be large amount of data, so we will divide it to parts with the block size of batch size, and we will train the model using these blocks, uh, and we will calculate the loss function, the average of loss function for all the block size. Then we will update the weight. As example, when if we have a data set of 1000 image and the batch size is 10 image, that means the model will take 10 image and use it as input and get output for every image. Then we will calculate the loss function for every image and we'll take the average. Then we will update the value of the hyperparameter or the weight. Um, of course, the lower number of batch size will be high efficient result, but will take much more times. And the higher number of batch size, it means that it will take a larger number of RAM or memory, and it will take lower time, and lower will cause to be lower efficiency. So you need to choose a balanced value that's suitable with your application. Third term that we have is training steps. And this term represent the number of the training round of using data block with the batch size. As example, we will use the same example. If we have a 1000 image data set of 1000 image, and the batch size is 10, and the training step is 10. That means the model is trained 10 times with the block of data with the size of batch size. Or in other words, the model is trained with 100 image. Now we have an important terms named learning rate. As I mentioned, that loss function will use to compare the real result and the output to calculate a value that used to optimize the value of the weight. Learning rate is used to determine the amount of that change, if it will be big or small. So it is a part of the equation that we'll use to determine the change in the weight value. Let's take an example to make it more clear. So let's take this connection as example. Let's say that the weight is of this connection is W0. And let's say that the equation, this is not the correct equation, but as an example, the new value of W0 is equal to the old one plus minus plus a value that we can have from the loss function multiplied by learning rate. So as you can see, the amount of change in the W old is limited by the learning rate. If the learning rate is big, the change would be also large. If it's small, the change would be small. So as example, if we have the perfect value for this one is 0.5, and now the value for omega old is 0.1. It maybe will jump a large step, so it will be the omega nu or W nu will be changed to 1, and next stage of training will decrease to also to zero point 0.1, and that will continue, which cause the overshooting, and it will never get the perfect value because we have large learning rate. So in this case we need to decrease the learning rate value. It is recommended that in the first few rounds of training, you use a larger number of learning rate. Then in the last few rounds, you need to decrease this value. That's the recommended for the learning rate. And the last terms we have is epoch. This term just represent the number of training round with full data set. It means that the model trained with all the data and dataset, then a number of times. Of course, you need to train the model with all the dataset multiple times you will get the accuracy that you want. Uh, Even if you trained and the model with the dataset multiple times and get good accuracy, you need also to try a new value or new real world image and see the result if it's good or not. So, because maybe the model will be good or just with the data set and the data and the data set. So you need to test the model with new data. If you will get also bad accuracy, you need to retrain the model with more data set, or you can use the same data set but by rotate the image or add noise. There's multiple methods that will resolve this problem. Of course, deep learning have multiple application. Now we will talk about the deep learning application. There's a vision application and natural language processing and word impedance. But for this video, I focus only about vision application. There's different terms that you need to know about image processing or vision processing. First thing is image classification. What does that mean? Your deep learning model will take an image and give just one title for this image. If the image is car, it say a car, just one object will detect. If it's cat, it will give a title for cat, and it can detect two objects in one image. In image positioning, and this type will locate that object and also classifying and give the title for that object. The third term is object detection. In object detection, the deep learning model will be able to detect multiple objects with different class or type and located in the image and classified every object in the image. As you can see, it detected two objects and classified every object of them. And we have the last terms that the more advanced, that image segmentation. That means that deep learning model can detect every pixel of that object. So it will detect, classify, and detect the position of that object. Then it will detect every pixel of that object, as you can see in this image. Here is an example for the image segmentation also. We have this is a tool that used for image segmentation. We have old version and the newest one. As you can see, the newest one is more efficient and improved than the old one. Can detect multiple objects that connect together and detect every pixel of that object. That was all for first part of that video. The next part will be about uh, trying an example using mindspore for image classification. See you later. Welcome back. We will try the code, first I will show you the installation guide for Python and mindspore. So first of all, you need to install Python 3.9. You can go to the official website for Python and scroll down until you reach the Python 3.9. I also will provide the link for uh, this Python and select the one that's suitable for like for Windows. Select this one. After you download it, you will get a program like that, installation program. Just open it and make sure to choose this option and continue the installation steps. After you install the Python on your computer, just you want to go to mindspore official website and select install option. You will get this window. Select the suitable option for you. You need to select this option. Then you select the platform. Ascend is Huawei NPU or Neural Network Processing Unit, which is a chip that made for deep learning purpose with very high speed. Also, you have the Coda, which is present the NVIDIA GPU, and at the end you have CPU. Of course, in ACID and GPU, it will be much faster than use CPU. But for as example, for my laptop, I don't have real NVIDIA GPU, so I will use for CPU platform. Then use your operation system for, as example, for me, Windows. Choose Python 3.9 to IP, and then all you need to copy this command and write it in the command prompt, and it will automatically download and install mindspore. After that, you need any IDE program to using to write code with Python. For me, I choose VS Code, which is for free. You can download it from the official website. And after download it, just go to this option and write Python. And just install this one like that. Will be option that say install. Now you are ready to write the code, so you need to copy the code. Also go to the mindspore official website, go to the learning, select tutorials and quick start. You will see this example. This example about the image classification of one digit number from 0 to 9, which means the model will uh, detect which number from 0 of 9. So if you give input image of number 9, the output will predict it is number 9. First, you need to download the dataset. As you can see, no need to use the Python code to download the dataset. So you just need to copy this link and copy the file. Download the file. After you download the file, just unzip the file to get the folders. Then this code, I already copied this code and made some change. So we will talk about this code. First of all, here you have a class, network class, which is represent the neural network. In this class, you will build a neural network. For a real situation, image classification situation, usually you need a convolution network. But in this example, the dataset is just contain image with 28 multiplied by 28 pixel, which means it's 512 pixel. So there is no need to use a convolution network. A normal neural network will do the job, and the input will be every pixel of that image. That means there will be 512 input nodes for every pixel. As you can see, this function is made a dense layer, as we mentioned in the part one of the video. Dense function that the network that the node connect with every uh, node in the next column or next layer. Here we have 512 input layer, then connected with the 500 also and 12, and this 512 connect with another 512, then it's connect with 10 output node. This node represents the prediction output for every digit from 0 to 9. This function used for to train, and this one used to test the model. Here is preparing the dataset image. The real code starts from here. These all are functions that we will use in this part. As you can see here, we specify the folder that we have that have the two file of the training. For training, you will have after download the dataset, it will contain four files. Um, two files for training, one for the image for training, the second file is for labels or the title for the image, or in other words, the real result. So this link path will be for the folder that contain the two files for the training, and this path will also the same thing but for the testing dataset. Here we specify the path size, as you can see is 64. You can try to change this number, see how it affects the performance of the code. We specify object with the network class, which means we build the neural network. Then here we specify the loss function, which it is the cross entropy. This type is suitable with the classification application. This value here is represent the learning rate. As you can see, the learning rate. The second parameter is the learning rate, which it is 0.01. Then we have the loop of training and testing. As you can see, the loop is depending on the epoch numbers, which mean the number of round of training using the all data set. And this part is for preparing the after completing training the model, we will test it with the real image. Of course, and for this program, it's a simple program that, with a small data set. It will not take much time, but in real situation, it will take much uh, longer time. So you need to save your model every round. So you to make sure that you will not lose the progressing in some situation. This code here in this code you can save the model, and this to use to load the model anytime. You can load and use this model. So if you training the model enough, you don't need to training every time you will need use it. Just you need to save it, then load it. Now we will test the program. Here we have two image, one digital image and the second is handwritten image, one for 3 and this for 4. So let's try it. Epoch is 5. Let's make it 10 or 5. And now it will start to train the model and test it. This is the training step. This is the loads value, and this is the number of round. This round 1, epoch 2. As you can see, after every round, you will see the accuracy and the loss value of the loss. It will repeat 5 times. Every time the accuracy is increased. Now is 94% accuracy. Uh, the image that I use is a.png, which is this is its number 3. As you can see, this is the product array. It's sorted from 0 to 9. It means this the probability of 0. This is the probability of 1, 2, 3, 4, 5, 6, 7, 8, 9. As you can see, this image is for number 3 with 28 multiplied by 28 pixel. As you can see, 0, 1, 2, 3. We have the highest probability with number 3. Of course, more training round will make this production more accurate. So here we have this number, which is 9, somehow close to the 3. But if we will increase the number of rounds, this result will be much better. But anyway, it's correct. Now we will try it for number 4. That uh, this one is not 20. The resolution for this image is not 28 by 28, but we will reshape it. Automatically will reshape it using this functions. As I said, there's no need to retrain it every time, but for now I will just run the program. You can just save the model and load it in any time. And we have the output 0, 1, 2, E4, not good result. What the reason? Let's see. Let's make it 10 and run it. Zero, 1, 2, 3, 4, 5. You can see now how the 5 addition round, how the the accuracy or the result, how it changed. Now the pre- prediction is correct, but it's also not very good result because it is near to be false. As you can see, this is the number 1, 2, 0, 1, 2, 3, 4. This one is near with this one, so we need to increase the number of round or until we will get better performance. Uh, anyway, that's all for this video. I hope it is useful, and you free to say your opinion about this video in the comment section. I will provide also this code in the link description. So bye.